Hey everyone, today we are going to solve the LeetCode question counting bits. So you are given integer n, return array answer of length n plus 1, such that for each I, answer I is the number of ones in the binary representation of I. So let's see the example. So we should check example 2. So n equals 5, output is 0, 1, 1, 2, 1, 2. So that's because binary representation of 0 is 0, right? So 1 is 1. And the 2 is like a 0, 0, 1, 0, right? Something like that. So that's why, so there is only one 1 in the binary representation. So that's why output is 1 here, right? So 3 is like a 0, 0, 1, 1, right? And there are 2, 1 in the binary representation. So that's why output is 2. So 4 is like a 1, 0, 0. So that's why output is 1. And the 5 is a 1, 0, 1. So that's why there are 2, 1. So that's why output is 2. Before I start my explanation, so let me introduce my channel. So I create a lot of videos to prepare for technical interviews. I explain all the details of all questions in the video, and you can get the code from GitHub for free. So please subscribe my channel, hit the like button, or leave a comment. Thank you for your support. Okay, so let me explain with this example. So you see the Japanese, but I think you can guess. So this is a decimal, and this is a binary representation. So to solve this question, I use dynamic programming. So how can we apply dynamic programming to this question? So let's look at from 0 to 3, and from 4 to 7. So did you realize that? So these are like a repeating work. So okay, from 4 to 7. So let's delete this one, and then look at the two numbers at the most right. And so 4 is a 0, 0. And so look at the 0 here, 0, 0, right? And look at the 5 and 0, 1. And let's go back to 1. So 0, 1. And 1, 0. So let's go back to 2, 0, 1. And then let's see the 7, 1, 1. And let's go back to 3, 1, 1, right? So that's why these are actually repeating work. So every time we count the number of 1, and then use the counting later. So let's look at the from 0 to 7 versus 0 to 7 versus and 8 to 16. So yeah, these two are also repeating work. So 8 is a 1, 0, 0, 0. And if we delete like a D and these 1, and 0, 0, 0 is so let's go back to 0, 0, 0 and 0, and 0, 0, 1. So let's go back to 1, so 1, right? And next 1, 0, 1, 0, and 1, 1, 1, 1, and 100, 100, 101, 101, 110, 110, and then 111 and 111. And then we go to next, like a unit, digit. One more important thing is that, so somebody wondering, so when we are like between 4 and 7, we go back to with 4, right? So when we are 4, go back to 0, and we when we are 5, we go back to 1, right? But when we are like between 8 and 15, we have to go back to 8, right? So go back to 8 and pointing 0. From we are 9, go back to 1, like this. So to solve this question, we should know when we go to next digit. So that's simple. Just 2, 4, 8, 16. And the next is 32. So yeah, I think you can guess like 2 multiply 2 is 4, right? And 4 multiply 2 is 8, right? And 8 multiply 2 is 16, right? So look at the 2. So 2, when we are 2, so we go to next digit, right? And then multiply 2 and look at 4. And when we are 4, so binary representation like go to next digit, right? And 4 multiply 2, 8. And look at 8. So binary is 1000. So 7 is 111. So when we are 8, we go to next digit. And let's look at 16. So from 8 to 15, so we use like 4 digits right here. But from 16, so we go to next digit and use 5 digit here. So that's why when we are reach like a 2, 4, 8, 16, this kind of we reach this kind of number. So we change the like a number as like a subtraction number. So I'll show you how to write a code later. And then so we can solve the like how many numbers we should go back. Yeah, so that is a basic idea to solve this question. So with that being said, let's get into the code. Okay, so let's write the code. First of all, initialize the DP list with initialized with 0, multiply n plus 1. And then, so let's say subtraction number start with 1. And then start looping for I in range and 1 to n plus 1. So why start from 1? Because decimal 0 is obviously 0, 0, 0, 0. So we don't have to care about the 0 because we initialize with 0. And then if subtraction number multiply 2 equal index number, and then update subtraction number with current index number. After that, update dp list equal dp minus dpi minus subtraction number plus 1. So why plus 1? So this one actually comes from the most significant digit. So let's look at from 4 to 7. So in the previous section, first of all, I delete the third digit from right, so this one. And then we go back to like a minus 4. So when we are 4, go back to 0. When we are 5, go back to 1. So that's because from 0 to 3, so we use a 2 digit, right? So that's why this DP list has number of 1 in the 2 digit, right? So from 4, we use like a third digit, right? So that's why this DP list doesn't have a like a third digit number. So that's why every time we need like a plus 1 for like the most significant digit here. In this case, third digit from right. So that's why we need plus 1. And then after that, just return DP list. Yeah, so let me submit it. Looks good. And the time complexity of this solution should be order of n because we iterate through from like 1 to n and performing constant time operation within each iteration. So that's why order of n. And the space complexity is also order of n because we create a DP list to store the count for each number. So that's why space complexity also order of n. Yeah, so that's all I have for you today. If you like it, please subscribe the channel, hit the like button, or leave a comment. I'll see you in the next question.